Today we need to talk about the distance formula. You may remember in prior lessons we talked about the distance between 2 points on a line. And we used something called the segment addition postulate, and we also talked about something called the ruler postulate. We were able to find distances in the coordinate plane so long as the distances were on a single vertical or horizontal line. For instance, if we had the point 5, 0 and a second point 5, 6, we realized we could tell the difference between these because the 5s tell us that they're on the same vertical line and their y values are 6 units apart. That is the absolute value of 6 minus 0, or the absolute value of 0 minus 6. Either way, we end up with 6 units. So that was pretty handy for us to be able to find the distance between 2 points on a line. Unfortunately, in geometry, we oftentimes run into situations where points are not on the same horizontal or vertical line. Of course, any 2 points are always on a line, but sometimes that line happens not to be vertical or horizontal. So what do we do in situations like that when the points are not on a vertical or horizontal line? We use the distance formula. This is the distance formula. It says that the distance between 2 points in a coordinate plane is equal to the square root of the difference of the x values squared plus the difference of the y values squared. Let's look at a quick example. Question says, find the distance between the points 3, 1 and 6, negative 3. Let's just take a quick look at that graphical representation in the coordinate plane so we have an idea of what it is we're looking for. The point 3, 1 is somewhere in this neighborhood, and 6, negative 3, probably somewhere in that neighborhood. So we want to know what is the exact distance between those 2 points. The exact distance between those 2 points. One of the things that's important to note is that if I wanted to talk about just the horizontal distance between them, I could easily do that. That horizontal distance would be this distance right here. That's my horizontal distance. That's actually the change in my x values. How far left and right am I going? And the vertical distance would be this distance right here. Okay? And we could actually find those pretty easily just using the rules we've already learned. When we talk about the x values of point A and point B, you can see the x value here is 3. That's this value, 3. And then it goes to 6 for B. So from 3 to 6, we can see that that is 3 units. The y values are at 1 up here for A, 1, and then down to negative 3 for B. So from 1 to negative 3, and you can see that's actually 4 units. But the distance from A to B is something entirely different. It's greater than 3 and it's greater than 4, but we don't want to just guess at it. We need to know the exact number. So we use the distance formula. Let's just plug the values in and see what we get. I've written the values into the distance formula. You can see I've put in the 6 for x2, and I've put in the 3 for x1. And then over here, the y values, I've put in the negative 3. Watch that minus sign. And then the minus positive 1. So here we have the difference between the x values and the difference between the y values. We need to simplify it a little bit. 6 minus 3 is 3. And minus 3 minus 1 is negative 4. Three squared is 9. Negative 4 squared is actually positive 16. So we end up with the square root of positive 25, which is equal to 5. So the distance from A to B is equal to 5 units. We could also write it this way, remember. AB equals 5. AB is the distance from point A to point B. So that's the distance formula. You need to memorize the formula so you can use it at any point in time. Some of you may be wondering, does this have anything to do with the Pythagorean theorem? It actually does. We'll talk about that later in the course about the connection between the distance formula and the Pythagorean theorem. But for now, you just need to know the distance formula. A couple things I just want to point out. First of all, these terms inside, this x, the difference of the x values and the difference of the y value are both squared. So no matter what those differences are, you'll always come out with a positive number. And that should make sense because the distance between 2 points is always a positive number. So for instance, if I were to ask about my distance right now from point Z, we'd probably express it as a positive number, maybe 2 or 3 feet. If I came on the other side of point Z over here and asked me, what is my distance from point Z now? Most of us would reply again with a positive number, about 1 foot or whatever the number happens to be. So no matter where we are in the coordinate plane, we always express distance as a positive value. And the algebra backs that up. When we square these values in here, even if we have a negative value, the square becomes positive, and therefore the square root is always a positive number. So distance is always expressed as a positive number. Let's look at one more example. Here the question says, find the distance between 0, 6, and 5, negative 6. And this time, without drawing the graphic representation, we'll just go straight to the formula. So D equals the square root of 5 minus 0, that's x2 minus x1 squared, plus the square of negative 6 minus 6, that's y2 minus y1. So the distance between these 2 points is 13 units. Notice again it's a positive number, and it will always be a positive number when we use the distance formula. That's the distance formula. It works whether I'm dealing with vertical lines, horizontal lines, or any line in between. It's important to keep that in mind. So as always, if you have any questions, send me an email.